Alright, so we were able to get px cubed, we got it to be 53 degrees to the nearest degree. Alright, now they want us to find the area of triangle WXZ. Not W. Wow, I can't read. Alright, I want to get the what did you say? The area. Wow. I need to get the area of the triangle YXZ. YXZ. Alright. I think I know why I said W. Anyways, so here we go. If we want to get the area of this triangle, we have theta. Alright, we have theta. Anybody has any suggestions how we may be able to go about getting the area of YXZ? Any suggestions? So I'm just gonna add a blank page in the meantime, but yeah, anybody has any suggestions? How are we going to be getting the area of the triangle YXZ? Any suggestions? Again with the struggle, oh my goodness. Okay, well, look, great. Yeah. Suggestions, anyone? Okay, so it seems like the dogs next door might have a suggestion, I guess. Okay, so let's see. I mean, you could want to do this question by finding some lengths, because one thing for certain is, regardless of the type of triangle, we at least need to know some lengths in the triangle to get the area of it, right? Yeah, we always need to have some sort of dimensions that we know. So I want you all to just take a quick look back at the original diagram, look at the information that they provided for us, and I want you all to tell me, what do you think you can do with the information that they've given here? What do you think you can do to be able to get the area of the triangle YXZ? So tell me anything you notice. Could be very tiny, minute detail that, you know, we may have overlooked. So, let me hear you. Yes, I'm hearing you. Yeah. There we go. This right here is the giveaway for it. Alright, so over here, notice that you have these two strokes. This represents that the sides are of the same length, and in particular on this side we have two strokes, because on this side we have one stroke. So what you notice here, and even from the information that we were given, they said that P and Q are midpoints of these respective sides. So if they are midpoints, it means it divides the length of the triangle into two equal portions. And here, if it divides it into two equal portions, then yeah, simple as that. This piece here will also be 7.5 centimeters. Alright, so here's also 7.5. And like I was saying, if on this side they are also equal in the same way, here's also 4.5 centimeters. So you have some options available to you in terms of how you can go about doing the solution to this question. Alright, one is, seeing as we have the two lengths of YXZ now, because we know that we could just add up 7.5 and 7.5 and then 4.5 and 4.5, and we'll get xy and we'll get xz. We could use that and use sine rule, and we'll be able to calculate the area of the triangle, which might be the easiest way for some of us. And then there's also the route of using similar triangles. If you could recall similar triangles, you could obtain the scale factor for the similar triangles and then use that information to calculate the area of yxz. Okay, so I'm going to give you all the options. So for those of us who probably remember how to use scale factors and the similar triangle properties, go right ahead and use that. And if you remember how to use your sine rule and you want to just use your sine rule because it's right there, go right ahead and do that as well and work it out. Let's see what you get as your area. So if we're using sine rule, remember what I just said, we're using 7.5 times 2 as the length of xy, so that's 15 centimeters. And then xz will be 4.5 by 2, which is 9 centimeters. And from here, we just apply our sine rule for area. Sine theta. Alright, so let me see if they had anything. Okay, they didn't specify degree of accuracy, so you could just work it out exactly, or you could round it off if you like. It's up to you. 135 by a half, which would give me 67.5, right? And then 67.5 by 0.8. Yeah, 67.5 by 0.8. Ooh, that would go to be a nice exact figure, which is good. Right, so you'll get 54 cm squared. Okay, so if you worked it out and you got 54 centimeters squared, so for those of us, if you worked it like I did, where earlier when we were calculating the angle, the magnitude of theta, we had a sine ratio of 0.8. So I just kind of worked with that, right? It was 0.8, and then that's how I would get 54. Even if you work it exactly, where you use sine of 53, you would still get something approximately close to 54. Right, you will get, let me tell you, 67.5 by sine 53. Right, so if you work it exact, you would get 53.9. Right, so like I was saying, if you do it this way, these answers are still correct. Both are still correct, right? Mine is just that I rounded off earlier, and that's why mine is 54. Even if you get 53.9 and you want to round it off, you can still round it off. Alright? So this is how you would directly apply your sine rule. We have the other approach, which I was talking about with similar triangles, that I'll show you all in case you can't really remember similar triangles, or in case you can but you can't remember what to do with it. So similar triangles would be those triangles that they look similar, but they are like one might be like a scale factor of the other. So one might be twice the size of another triangle, it might be half the size of another triangle. That's when you know you have similar triangles. Once you notice that the sides are, as we see here in this particular diagram, you can see although it's a triangle within a triangle, you can see the similarities because the sides are, congruent to each other. So here you can tell from just the diagram itself, you could utilize similar triangles for this second part in particular. Alright, and to utilize the property of similar triangles, what we're going to do is this: we're going to obtain the scale factor. Okay, if we can obtain the scale factor, there's a relationship between the areas of these triangles according to that scale factor. So based on the diagram, alright, if I want to get the scale factor of what's the side xp, alright, so if I want to get the scale factor of x y to xp, I will divide the length of xy, which is 15, by the length of xp, which is 7.5, and here I will get 2. Alright, and even just by looking at the values from earlier, you could tell that the scale factor would be 2 as well. Alright, so with the scale factor obtained now, so the area of yxz, since these two triangles are similar, alright, the area of yxz is equal to k squared times the area of what was the little triangle called again? qxp, right? Right, so we can get the area of yxz like that using similar triangles. So the area is equal to k squared times the area of qxp, which was 13.5 cm squared, and this would work out to be 4 times 13.5, which would give me 54 centimeters. Alright, so both ways can be used. Right, both ways can be used to obtain your area. Alright, one way is using sine rule and the other way is using similar triangles. So because this is a trigonometry question, you will get your marks regardless of your technique once you use your approach properly, and once you substitute and you evaluate it properly. Alright, so make note of the fact that, like I say often, when you know all the different things, all the different basic bits and pieces of knowledge for a particular topic, you are more readily able to apply all those little pieces of knowledge to help you as necessary. Okay, so whichever way you do the work in here, you would still get the same answer. Alright, so anybody has anything that they want to ask pertaining to what we just covered here? Okay, are we all good to go with this question? Okay, so I heard a yes. Thank you.